He's Julian, and I'm Benjamin Strostrup. Okay, Colonel Wilkinson. Thank you. At least you understood the bad joke. So I want to start saying how type systems can be categorized, because we usually believe that there are only two categories, and if you know a little bit more about type system, you will see that there are more than two. The first one is related to when to do the type checking. This is the most common one, and we have static typing like Java, C#, C++, etc., and dynamic typing, Smalltalk, JavaScript, and so on. And remember that even though you have static typing, when you have subtyping, you have to do some type checking dynamically, like, for example, downcast and so on. Have a type system. The other category is that it could be a strong typing, like Java, C#, so on, and weak typing, like C, C++, and maybe JavaScript, Visual Basic 6 could be weak typing. And that's the the idea is what the type system or the language does when you break the system, the type system. For example, Java doesn't allow you to assign a long to an int, but in C you can do that because it's your responsibility. There is a lot of talk and history about why it happens like that, but I don't have time for that. So Smalltalk is a strong type. Who's doing? Somebody's doing that in purpose. I know. Okay. But there are other categories, like, for example, how the elements are typed. A variable, a function, a method, and so on. So we have explicit types like Java, C#, inferred types like TypeScript, Haskell, SML, and collected types, like in LiveTyping. And also how types are defined. Most of the types we know are by name, like in Java, C#, and so on. But you can also have something that now is more popular called structural typing. That's what TypeScript does, and we have been doing since the 70s. Okay, just if you didn't know, with Smalltalk you're doing structural typing. Okay, so now you can say that and say, oh, we're like TypeScript, we're the top of the hill. So anyway, with Smalltalk, with LiveTyping is dynamic, strong, collect, and infer type for generics, and structural typing. Okay, so what's this? That makes sense to have a type checker in such a system. So I want to be clear about this, because the goals of the type checker of LiveTyping is not the same goals that you have on statically typed languages, and that's why sometimes people don't understand it. But our goal is we don't want LiveTyping our type checking to stop you from compiling. That's not the idea. It's not the same idea as a statically typed language. And it's not the idea to improve performance and those kind of things, at least not yet. Maybe we will do it someday. The goals are to help the programmer with possible type mistakes and to provide better user experience. Like, for example, when refactoring, when using the autocompletion, or those kind of things. Oh, I think so I changed that, but what I'm going to do is show an example of how the current type checker works on Quiz with LiveTyping. So what I'm going to do, I'm going to type check the collection class, okay? And this is an interesting example because there is a type error in collection. And the type error is that string contents is sending string contents is sent to species, and a species could be an instance of a set. And a class doesn't, and that set doesn't implement the string context message. So here we have a set. If we send the message flattened to it, No, 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 no. Let me look at the versions. Oops. Well, I'm sure it wasn't my idea. So, okay. So if you send flatten to it, it will have an error, okay? So this is an interesting example of how the type checker can help you to find common type errors that we don't usually see because of hierarchy stuff and, difficult things to see. Um, and what are the problems with the current implementation of the type checker? So this is a example where, just to show you the problem, this variable types is order collection, small integer, date, string, whatever. But here it says, okay, if it's a collection and it's a class and it's a string, so if true, send the message as lowercase to it. If we type check this method, the current implementation of the type checker will tell us, this is an error because order collection, small integer, and date do not implement as lowercase. But that's not really an error because we filter, the type. Also, we have another issue. For example, in this case, it will work because it's not using the AND, but just if true, if false, if true, is false. So the same example works, but it depends on how you write the filtering. And finally, just to show you that this is not implemented in the, it's not integrated with other tools like the autocompletion or the one that shows you the type of a variable. Here it says that var could be order collection, small integer, date, and string, even though we know that it should be date. No, it should be string. Okay. So those are the limitations of the current implementation, and those are the things that we wanted to fix, and that's what Julian did.
All right, thank you. Okay, so basically, as part of my master thesis work with Hernan for the University of Buenos Aires, we decided to tackle these issues, and basically, as you saw here in this general schema of LiveTyping, type checker was originally integrated with a feature called cast and reject appliers, and that was like highly coupled. So we want to increase the type checker cohesion, limiting its responsibilities only to the fact of do the type check based on the type information coming from somewhere. Therefore, reduce the coupling with this functionality of cast and reject appliers, complete its missing features like supporting the and or messages. And by doing this, we should be able to extend this functionality to the code completion, the auto completion, and what Hernan just showed, which is the variable inspection. And also develop all of this over the generics work, which is a previous master thesis that basically improved LiveTyping with the being able to support generics for example, for collections. Now, instead of having just an order collection, if you start assigning items to it, you could know that inside that order collection you could have integers, dates, or whatever. Okay, so how did we do this? Basically by creating a new context appliers feature, no more cast and rejects, a new one that interacts with LiveTyping, receives types from LiveTyping, and transforms types accordingly to what that context is trying to capture. Then develop a new type checker feature over generics that will assume that always, all the time, types are context aware, or that are correct. And finally, extend these context appliers to type checker, code completion, and variable inspection. So to give you a little bit of the motivation, besides the example that Hernan showed, here we can see again the same collaboration, var as lowercase, in 3 different scenarios. In the first one is the general one. It could be a type error if we run the type check there. because, well, as lowercase is not implemented in date, small integer, or the collection. But in the rest of the two, the developer makes sure that the context enclosure in that block node, it's correct. So in the second example, it's saying, hey, I'm only want to do as lowercase if I'm sure that var is a string. So we should capture that, and we should create that context inside that block, because inside that block, we know that var, it's a string, and just a string. And the same for the third one, but it's filtering out one type at the time. So the idea is moving from this to this, basically, with context appliers as a new feature depending on LiveTyping and providing information to other features. So I guess I can show you an example. Basically, we have the same method than before. I will run a type check. And here it's saying that there is a type error in var as lowercase, but no risk in which var as lowercase, in the first one. And it's saying that as lowercase is not implemented in order collection and date, but it's not saying anything about integer. And that is actually correct, because we just filter out integer. Also, you can notice that it's not showing any error in the last collaboration. So this is working, and also you can see that in this context, this should be working. In this context, the general one, var is date or the collection of something, small integer and string, but here it's no longer an integer, and here it's just a string. So that's what we want. Here we have this context awareness part of the thing. Thanks, Juan. Sorry? The whole idea it's build the context properly. So in this example, we need to build a context where var is a collection for the if true part based on that inside that block, and for the false part of the statement, build a context where var is not a collection, just the, and therefore calculate the types accordingly. How did I do this? Basically, what with TDD, creating a new method as a test case, and saying which is the context interested in calculate the types, and which is the node calculate the types. Out of these strings, it will get the actual block node and node variable, wherever, and then asserting the types that I want. So the key elements to perform this is to have the compile method, the target node, and the block node that will serve as context. So hopefully we will see it in action again, but a little more into detail. So if you take a look at this example, this just simply is trying to cast B1 as a small integer. So let me run this. That it's basically doing what I just showed you, getting the actual block to test, B1 factorial, and I want to test against B1. So hopefully at the end of the day, types will return just small integer. How is this ignore all the halts, it's just for this presentation. By creating a visitor that will be iterating through the whole compile method, using the AST information and visiting all the nodes. So that's basically the key part of how to do this. And again, ignore all the halts. The whole idea is that we are going to visit each block node inside the compile method. And as long as we don't find the one that we are looking for B1 factorial, as you can see here. And as long as we don't find it, just keep looking. But if we find it, okay, ask the live type, ask the types. Live types is because it's implemented over generics now. to the current context applier. Right now, the current context applier is the general one, which will forward everything to LiveTyping. Then we visit the message nodes. I think we can ignore this one. What's important here is that we care about all the possible combinations between if true, if false. So we have one here. You can see it in the right. So this we care about. So many helps. OK, so basically what we want to do is to see if we need to update or not the context. And for this case, we know we need to update the context because we have an if there. Once we have that, I'll show you later what this should update for message does. But basically, right now, we have a new context that will serve as the current one for the method that we are going to visit next, which is the one that we are looking for, this one. And I can show you the new context for you to take a, for you to know what it's about. First, it has a reference to the previous one, so it can be restored after it visits the whole block. Then it knows, by inspecting and analyzing the condition, that it should be applied to B1, and that the type is a small integer. This is one kind of all the possible context, the one that can either cast or filter types. And for this particular one, it's not going to filter, therefore it's going to cast. OK, so now it's going to visit the new block with this as the current context applier. So when we get to the block node again, now they're matched, and now the context applier is the one that we just built. And when we ask for the types, well, here it will ask if it should filter or casting, in this case, casting. And casting to a specific type is just as simple as putting that as the type. So if we proceed, the result is a small integer, and it's working. OK, now I have one more and last, I promise, example to show you. This is a little bit more complex because it's how the nested ifs works. So let's do this again. This will be a little faster. Here we are again visiting the, if you don't remember the method, it's there. We are again visiting, and now we are in the first of the two ifs. Here, as the opposite of the previous example, we want to filter small integer instead of casting it. Yeah, so it will create exactly the same context that I just showed you before, because it's basically doing the same, but this time it says that it's going to filter instead of casting. But it's the same. OK. OK. That will serve as the current context for the whole block. And the block that is going to visit with that as the current context is the second, basically, block that contains the second if. So we proceed to that. Oh, yeah, OK. And we are again, but now we are visiting the second if, the nested one. And the current context applier is an equals. And again, it will, oh, sorry. You halt. And again, it's going to ask if it should filter or not. Sorry, if it should update it or not. Let's take a little look to that. But basically, what we need to know is if we are if we are rejecting the condition or not. In this case, we are in an if true, so we are not rejecting the previous condition. So that's the outcome of that. And then out of the whole message, we get just the condition, which is another message node. And with that condition, which is basically the is string, sending to B1, we want to see which context do we have to build. So this is another message node, and the way we did this is by asking questions to the message node to see which one is it. You will see a lot of ifs here. Maybe we could improve it later. But again, we will need to spread all of this logic to all the selectors. So it's a debate if we should do it or not. So far it's here. Okay, so if it's not an OR, it's not many OR, it's not comparing equality, blah, 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 it will detect which one. It's not kind of, it's not nil, but it is an is type, returning a Boolean. It's going to build that context. What's interesting about this context is that it's not fixed to only existing message, like is string, is collection, is integer. It basically can support any custom message that we create, as long as it starts with is something, and all the implementations of that messages, of those messages, all the implementations returns a Boolean. If that's the case, then we are going to support it. So without any extra effort of development. So that's why we pass the selector symbol to this context. I don't know which one is it. Here we know it's string, but it could be anyone else. Any other. Okay, so we proceed, and what's interesting here is that this new context is the one that I just showed you, that as previous, it has the equals context, and that equals context as previous, it has the general one. So we have this linked list of context appliers. And at the end of the day, when we visit and we find the block that we want, the one that we were looking for, B1 as lowercase, and ask the live types. Here again, we're going to casting. This will be a little more complex because we want to cast to that is something message. So we are looking for all the implementers of that message returning true. And take a look at this. The original types for this context of B1 are just order, collection, and string, but not small integer. And why is that? Because we ask for the original types to the previous context. And the previous context already knows that B1 is not longer integer, so it's not returning it. Okay, and here for all the types, it will look if that selector exists or not, and if it does, in this case, it will be check if it's returning true, because we want to cast. Out of that, we only have string as result, so that's pretty much it. We proceed, and that's how we have the string as the final result. This is basically how all of this is working. Okay, so to have the bigger picture of it, at the end of the day, we will end having kind of bisection between all the nested ifs and the context appliers build. Each one will have a reference to the previous one, and all going back to LiveTyping. These are all the context appliers that I built. The equals one and the is type I already showed you. The is kind of takes care of the is kind of message. As you can see in the this is type, I implemented this is employee and it will work. Then the equals to literal, and also the logical to solve for the and or message is no other thing than a combination of two other context appliers. So recursively, this can support all of the combinations of and or that we want. And if we have an and, then the final outcome is the intersection between the types of the left context applier and the right context applier. And if it's an or, it will be the union. And inside those, you could have more and or nested. So this will be solved with recursion, basically. Okay, that's it for the context applier. Now, how is this integration for the new type checker, which it does basically the same as before, but without taking care of all this context. So as you can see in the original implementation, all the types was requested directly to the node, and that means request the types directly to LiveTyping. And then by getting all the types of the receiver, it's checking if the message being sent currently is implemented in all those types. The whole point of making this context aware is just changing that to ask the same to the context supplier, and of course keep the context supplier updated as I just showed you, doing exactly the same. So we go to request directly from LiveTyping to request to the context supplier. And that's the whole change we need to do in the type checker for this to be done. Finally, for the code completion and variable inspection, basically we need to base all these for the position of the cursor or the mouse. So based on the source range dictionary of the compile method, we try to detect if we are inside a block node or not based on the limits. If we are not, then we keep the original path, which is the one on the left, requesting, as you can see, directly the information to LiveTyping to the node. But if we find the block node, then we pass it along until and fork to this new calculate types with context. That again, as you can see, now the types are being requested. The types of the node are being requested to the method, to the compile method, and it's giving the block node to analyze. So with this information, it will create the context and as the types as I just showed you. Okay, so that's basically what it's done until today. Hope to get my degree with that. For future work, the idea is to integrate these two things, both generics and the new context appliers and type checker to quiz official version, Juan, hopefully. All context adapted work was done only by analyzing if true, if false, if nil, if not nil, all possible combinations. This could be possible extended to while true, while false, even though those cases are more border cases where the while condition interferes with the type inside the block, but could be. And also, no performance tuning was done. There's no need because this responds fast enough right now. But as you can see, it's not the same to go directly from LiveTyping than doing all the analysis of all the conditions to create all the context and then ask all the types. There is so much more overhead that maybe we could improve somehow. So there's open field there to investigate also. That's it. Gracias.
Questions.
Hi, in the case that you are doing the type check with the, I don't know, bar class equals integer, if I extract the method, I take this code and do extract method and create a method, it will continue working or analyze the...
No, it should continue working. It will all depend on which variables you are working on. The examples I showed you are all with local variables. So if the extract method works correctly, then everything will work. This will also work with instance variables. That's the more interesting cases, actually. And yes, it will continue working because here it's all about, I mean, we still strongly rely on LiveTyping. So as long as LiveTyping continue working, this will continue working, and we know that LiveTyping will continue working on those cases. So the answer is yes.
Because in that case, the extracted method will be return a Boolean.
Yeah, no, but this also takes care of the types being returned by. The examples I showed you are just assignments, but with the returning nodes, it will continue working. Yeah,
okay.
It's the same.
Thank you.
You mentioned that you also have implemented with an is something, is integer, is string, and it should work. What happens, or does it get confused? And if you have an is method, like, I don't know, is all or is retired, where it's not a type information but a Boolean method, does it get confused or it works properly?
Sorry, can you repeat that a little bit louder?
Sorry. You mentioned that it works like with is something method when you encode types with a method. Does it get confused when you have an is method which encodes another thing, for example, is all or is retired, which does not encode types? Does it get confused or it works as is?
Let me see if I understand. So if the is method is message implementation send another is message, is that right? That's what you're asking?
No, for example, you
Decirlo
have
en castellano.
si tenés un método que pregunta, por ejemplo, si es viejo o si está retirado, que no codifica tipos, sino que pregunta algo. ¿Eso confunde al sistema o sigue funcionando correctamente?
No.
It will depend on if all your hierarchy, for example, that you have one, all answer the question of is all or is retire, then in terms of typing, it will be the same. The original types will be preserved, basically because all can answer the question is all or not. But now, if you have different implementations for is all and for example, boy answers is all to false and the rest true, for example, and if you have some variable that could be based on LiveTyping a boy, and you ask if is all, then inside the method, it will filter out boy. So that basically depends on how you implement and who answers is boy.
Yeah, I'm sorry. And one other thing, when we look for what an is message is returning, we look at the type, not its implementation. So if the return type of is something is true, or if it's false, we don't care about how it is implemented. So that's why it works.
Okay, I have another question. I have another question, if I can.
Okay.
Regarding performance, you mentioned there's no test yet. Have you ever tried it on a large system? Because if you are having a lot of context per method or per block, that's going to probably have an impact on performance on large code bases. Do you have plans to test it or not yet?
No, yeah, exactly. No, that's why there's open field to investigate it. For the use cases that this was meant for, we could test that there's no performance issues, but we are aware that the overhead should be considered. The direct answer is no. So
Yeah, but remember that when you always check in for a method, and all the type information is there. Parameters, variables, instance variables. So it could take more if you want to check the whole category of class, but even though it's really fast.
Right now, I see types as variables being members of classes, but there are interesting types that are subranges. So the positive integers, the letters amongst the characters. Are you going to extend so that you have a richer notion of type than class membership?
Yeah, I answer that. Yeah, that's an interesting field of research. Right now we are coupling the notion of type with class, and that's not correct. But yeah, that's right. But we did that because it's what we usually do, but we should have like a protocol. The problem is that in Smalltalk we don't name those protocols, so we have to look away for that to be usable, understandable, and not to interfere as a Smalltalk programmer. because we don't want live typing to take any time from you. So that's why it collects types. It doesn't tell you to write the types. It does everything for you. So in that case, how do we get the name of that protocol? That's the issue.
If that's it, thank you very much.